In this video, I'm going to be using different colors of marshmallows and different sizes of marshmallows and toothpicks to represent atoms and molecules and extended structures and a few other things. So imagine that these marshmallows sitting on the table are different atoms. So this could be an oxygen atom. This one, it's actually red. It's hard to tell on the video. You can see it better whenever there's not a red background or a pink. But this pink one here, it could be hydrogen. This orange one, you can't hardly see that that's orange, but this orange one here could be a tasty treat, or it could be sodium, and this could be another type of atom. So to demonstrate these being molecules, I need to get a few bonds going on here. So the toothpicks are going to represent bonds. And again, this one, for the purpose of this, is going to be an oxygen atom. And this one here is hydrogen. And I'm going to get one more hydrogen out of the bag. Zoe still really wants to eat my presentation here, but she's going to have to be patient. So, we'll start off using the toothpick. Give a bond to that hydrogen. Give a bond to that hydrogen. Pop them into the oxygen. And voila, you have a walking molecule that's actually a model of H2O. So not only can we model just regular molecules from these marshmallows, we can also use them to make extended structures. So what I'm setting up here is going to be sodium chloride. So I'm going to pause the video and come back whenever I have my full structure, as long as it's not eaten. Oh yeah, you try to be innocent. And voila! There is sodium chloride. That's your standard table salt. One drawback I have found from using marshmallows to do this and toothpicks is the fact that it's kind of hard to make a 3D structure. Like, I can make it flat like that, and you can see that it's a continuous structure. But to make a 3D structure, I should probably use less toothpicks to make it structurally sound. Otherwise, it wants to fall over. I tried to make it 3D, and it just wanted to keep collapsing on itself. Not only can you demonstrate extended structures with marshmallows, but you can also demonstrate states of matter. Right now, I'm going back into the water molecule demonstration I had before, and the way I have them arranged is just like ice. The molecules are all stacked together neatly, kind of like they would be in ice, but they would still be in motion. So one problem that you have is that you're not illustrating that they can still be moving while they are in these forms. And if you wanted to illustrate water, just kind of move them around a little bit more. Rearrange them. They're not so closely stacked together, but they're also not really far apart. Now, if this was water vapor, you could toss them all over the place, especially if you had a bigger table. Right now I'm using a small table, but you can arrange them, spread them out like that, and the students can see that, well, whenever it's in gas form, they are further apart. But you still can't show the movement of them that easily unless you have the students wiggle them around. You can also use them to show how several atoms of the same type can come together to form a molecule. Right here I've double bonded these. These are representing carbon now, And so it's a carbon ring, C6, and they're put together with double bonds using 2 toothpicks. One issue is trying to make more advanced structures again. You can't really have a lot of stability, and you would use a lot of marshmallows. You can also demonstrate molecules of O2. These are oxygen now. I know they keep changing what they are, but they're double bonded O2 molecules. Because their valences are completely full, they do not attract to each other. They don't want to make connections with each other. It's hard to show those attractions, though. It's hard to demonstrate to students that these are full valences because they're just marshmallows. And along that same train of thought, it is really hard to demonstrate how individual atoms are not attracted to each other like helium, because with marshmallows you just have that structure of it's just a round structure. Another issue you can come up on is trying to demonstrate very complex structures like sucrose. For a basic lesson on atomic structure and bonding between atoms and molecules, marshmallows are a great way to go, but they have a lot of physical limitations. They're squishy and they want to break apart whenever you put too many toothpicks in them, and you can only stick so many toothpicks in them. Making advanced structures is hard. I would suggest something like Legos or Connects. But in the end, they're a tasty treat to have. And for a good little lab assistant, dance. Speak! They can be a great way to make your dog happy.